We are proving that z to the square root of 2 has infinitely many values for every complex number z except 0. First, we apply the definition of z to the alpha, and then the definition of log z, and then the definition of arg z to get to this point, where z to the square root of 2 equals absolute value of z to the square root of 2 times e to the I square root of 2 principal argument of z times e to the I square root of 2 times 2k pi, where k can be any of these integers, 0, plus minus 1, plus minus 2, and so on. Now, to prove that z to the square root of 2 has infinitely many values, we will prove that if we take two different values of k, like k1 and k2, and we plug them in here, we produce two different complex numbers. That's what we are proving. So suppose that we don't, for a pair of k1 and k2, we plug them in here, and the resulting complex numbers are the same. If that's the case, then the arguments must differ by a multiple of 2 pi. So here it is. We take two different Ks, K1 and K2. We plug them in here, and then we take the difference. We set it equal to 2L pi, where L is some integer. Now, we want to prove that this is false. It's impossible. We cannot make these two arguments differ by a multiple of 2 pi for different k's. So let's see why. Divide both sides by 2 pi, and then factor out the square root of 2. We get this square root of 2 times k1 minus k2 equals L. Since we are assuming k1 and k2 are two different integers, we divide both sides by k1 minus k2. Then we get the square root of 2 equals L over k1 minus k2. What's wrong with this picture? We know that L is an integer, k1 and k2 are integers. The difference of two integers is an integer. An integer over integer is a rational number. So that means square root of 2 is a rational number, which is false. Therefore, it is impossible to take two different k's and get the same complex number here. Therefore, all of these are different complex numbers, and there are infinitely many of them. So z to the square root of 2 is a multi-valued complex function, and it has infinitely many values for every complex number z except 0.